If you like my dad's videos, please subscribe to QA Insights channel.
So in our last video, we have seen about how you can start the Vault server using the file backend. So file backend, it works, but it has one major weakness, which is it's a single point of failure. So in our first video, we have seen in memory using the dev mode. When you terminate the process, all the data will go away. In last video, we have seen the file, so the data will be persistent. But in some instances, the data might be corrupted or the node will go down. At that time, you will have the single point of failure. So for any real world use, you need high availability, HA. So this means if one server stays online and the service should still work. That's the expectation. So today we are going to build a true production ready 3-node Vault cluster in local, and so that we can see how the high availability works. And for that we are going to use Vault's built-in Raft storage. So by end of this video, you will have a fully functional HA cluster and you will understand how Vault protects itself from the server failure. So for that, we are going to spin up a 3-node cluster. We are going to simulate that. So to demonstrate the idea of this particular demonstration, so now let us say we have 3 servers, which has the Vault running. And here you have the client, and the client will send the requests, say, to each node. And unfortunately, one of the pod or one of the node goes down, then the request will not be able to process in a typical scenario, right? But these 2 nodes or 2 pods will be active and continuously serves the requests so that you can read and write the data to the Vault. So this is the illustration which we are going to achieve using the Vault built-in Raft integration storage. So this Raft has a very beautiful consensus algorithm, which you can read it more by searching it. So if you search for Raft protocol or Raft consensus algorithm, you will get a lot of information. So to dive deep, as usual, you need to have the Vault installed. If you do not, please visit my previous 2 videos on how to get started with the Vault. And we are going to create each node directory where we can store the data, and we are going to initialize the Vault. So you can use the make directory command to create these 3 directories, and we are going to start the node one by one. So we are going to initialize the first node using this particular configuration, and we are going to init the Vault, and we are going to unseal it, and we are going to log in and see how the HA works in the Vault cluster. Now let us dive deep inside this HCL file. So this is our Raft node 1.hcl. So here in the previous video, we have seen the storage type as file. So now we are going to change this storage type as Raft. So Raft takes at least 2 arguments, key value pair. One is the path where you want to store the data and the node ID. And similarly, we are going to listen for this node. So this is the first node which we are going to spin up. So in production, you need to enable the TLS. And these are the API and the cluster addresses, which are very important for HA. So API address is for the client, which initiates the communication. It could be some backend program, or it could be from the browser. So this is the address which will communicate. And the cluster, this is the port which handles the between the nodes. So between the Vault nodes, if the Vault node able to communicate with the other node, so this is the cluster address it will be used. And UI equals true, just to see for the demonstration purpose, but in the real world, we will disable the UI flag as false. In Raft node 2, we have to tell this particular stanza, retry underscore join. So here we are telling the leader API address, which is the first node, which is at 8200. And rest everything stays the same except the path here, a node ID, and the listener for this particular node. And here the API address is 8202 and the cluster address is 8203. And similarly for Raft node 3 as well, we're going to configure the respective directory and node ID. And again, we are going to tell this particular node 3 should contact the leader, which is the first node. And similarly, listener TCP address 8204 in this case, and cluster address is 8205. So even if one of the vault node, which is active state, goes down, other node will pick up the leader using the follower, and then it will become active and vault will continuously serves the request. So this is the theory part of the particular section. Now let us dive deep into the hands-on. So for that, I'm going to open the terminal warp. So in case if you need AI in your terminal, please check out the warp, a link in the description. It's a referral link. So now let us begin using let us create the node directory. So right now I am in this folder. So as you see here, we have console and Raft. In next video, we're going to see console, and this video we are going to focus on Raft. So now let us go into the Raft directory, and we are going to start with creating the node directory for each node. So for that, I'm going to copy this and paste it, and make sure the path which you mention here, it is matching. So we are going to use the current directory /node1-data, and similarly node 2 and node 3. So now if you see here, we have node 1 data, 2 and 3 data. So each node will store the relevant data inside this directory. So now we are going to start with starting the Vault server using this configuration. So in terminal 1, I'm going to use this command, which will start the Vault. And similarly, I'm going to duplicate this, and I'm going to start with node 2. And similarly, I'm going to start with node 3. Now, before we proceed further, let us start observing the output here. So here in the node 1, as you see, the storage is Raft, HA is available, and Vault server started, log data will stream in below, and starting the event system. So that's the latest output we can see in the terminal 1. But in terminal 2, there are some failures because we started the Vault with the Raft configuration. So it is expecting the node which needs to be healthy, but right now it is not. Even though the node is up and running, the Vault is not initialized and Vault is in sealed status. So if you don't know about these two, please watch the previous videos about these two concepts. Similarly here, a Vault is sealed and we are getting 503 error. So now let us initialize the Vault using the Vault operator init. So before that, rookie mistake, we have to set the Vault address. So we are going to set the Vault address as 8200 in the terminal 1. So now let us initialize the Vault using the Vault operator init. So this will give us the unsealed keys and the root token. So we have to store these root token and the unsealed keys in a secured place. But in production, people usually don't do this. Once you set up, the Vault is setup is done, you have to toss all these root token. So you have to focus only on the unsealed keys and you have to dispose the root token. That's the best practice. So in this, for the demonstration purpose, I'm going to store these because we need these keys to unseal and log in into the Vault for the first time. So I'm going to navigate here and let us create a new file, say a token, and paste it here. So now we have initialized the Vault, and now it's time to unseal the vault. So I'm going to use vault operator unseal, and we need by default 3 unseal keys to successfully unseal this particular vault. So I'm going to copy this in a random order, again the second key and third one. So now if you initiate the vault status command here, and as you see here, initialize equals true and the sealed status is false, which means the vault is now up and running. And once this particular node is up and running, as you see here, the error has gone, but there are still errors, but the 503 error has gone. So here if you closely watch these errors, so here it is saying failed to retry join Raft cluster, waiting for unsealed keys to be supplied. So initially it was like 503, but now it is throwing this error. So basically these two nodes as well in the unsealed status. So we have only initialized and unsealed the node 1, but not node 2 and node 3. So no need to initialize the node in this case. We have to only unseal the vault. So for that, again, I'm going to split the pane to the down. Here again, same split pane down so that we can easily see. And again, we are going to export using the cluster vault address. In this case, it is 8202 for this particular node. Again, vault operator unseal, pass all the 3 keys one by one. Okay, now vault status. So here again, initialized equals true and sealed equals false. So again, repeat the same. In this case, vault operator unseal. Again, export to 8204. So now let us use the vault status. And here also, as you see, the initialized equals true and sealed equals false. So now all the 3 nodes, the vault is unsealed, and we have in it only the node 1 and the rest of the 2 nodes are unsealed. So now let us log in into the first vault. So, but before that, let me just quickly show you one more thing. Here, the HA mode in all these 3 nodes, just note this. So HA mode is active here in node 1, but in here it is standby, and here also it is in standby. So these 2 nodes will be in standby mode, and one of the active node goes down. Any one of these nodes will become active. So from standby it will become active. We are going to simulate that, but before that, let us create a login and create some secrets using the KV-v2 and put some key value pair. So just to see the difference. And before that, let us also log in into the UI so that you can also see what's going on in the UI front as well. So we are going to use the 8200, and I'm going to copy and paste the initialize the root token, the first token we got it here. Sign in, and here as you see the monitoring under monitoring section, we have the Raft storage. So right now under Raft storage, you can see there are 3 nodes, and the leader is 8201 and the voter is yes, and remaining 8203, which is not the leader, basically it is not in the active state, but it can vote. And 8205, it is no, and the voter is yes. So here you can also remove the particular node in case if you don't want, or it's become unhealthy, or just to maintenance, you can take or remove these out from the cluster. And here you can also download the data of these storage, and also you can restore the data. So these are from the UI, but mostly in production they don't enable UI. It's not highly recommended, only via the CLI commands. So now let us go back to the terminal and let us log in using the root token which we got. And similarly, I'm going to log in here, vault login, and similarly in the third terminal. So now we have logged in. So now I'm going to enable the key value pair. You can do it any nodes. So in this case, let us start with the second node. So I'm going to enable vault secrets, enable kv v2. So let us go with the default path. So here we have enabled kv v2 secrets engine at the path kv-v2. So now if you go to dashboard, and here as you see, we have created kv_v2, kv-v2. So here we are going to put some key value pair. So now let us do it in here in the third one. So vault kv put and kv-v2/app and say colors equals blue. So now we have the colors equals blue as a key value pair, and if you go back and come inside, as you see under app, we have the secret, and if you just click here, you can see the value. So now you can also go to the first node, and also you can get the same value, vault kv get and kv-v2/app. So here also you can see. So all the three nodes will work. Even if it is a standby, the request will forward it to active node, and then active node will process it. So internally, we don't know those internal details. It's like a black box for us, but basically it will take care of everything. So now we are going to simulate the failures. So as you see in the node 1 vault, if you hit vault status, and we have h enabled true, and also mode equals active and active since. So this is the particular node 1, right? And I'm going to kill this particular process. So I'm going to Control C. So now as you see in the node 2, and there are logs in node 2, right? So it is trying to connect to the leader node, but it is failing basically. So it is not able to connect, and it will do that consensus algorithm. So basically it will choose one of the standby node as a leader. So let us wait for a few seconds, and then let us check the status either in the UI and also either in CLI. So let us use the CLI here, and let us use vault status. So as you see here, it is not available, and here let us check vault status. So now as you see here, HA mode becomes active. It was a standby mode. Now it has become active. And similarly, if you see the node 3 vault status, and this is still in the standby mode. So now let us put some other value. So vault kv put, and in this case I'm going to change this to red. So now it still works. So now if I get vault kv get kv-v2/app, and the colors equals red. So basically, even if one of the node is failed, not able to say down due to some maintenance, the other standby node will become active, and it will start taking the requests. So now let us go to the UI and go to home. Basically this particular node is down now because 8200 is down. So now we are going to use 8202, and let us log in using the token. And if you go to kv-v2 and app and secret, and here you can see the updated value. And again, if you see in this particular monitoring section, Raft storage, the node 1 lost its leader status, but it can still vote. Once it is up and running, it can still vote, but node 2 will become as a leader node, and it can vote. And again, node 3 is not a leader, but it still can vote. So now let us go back, and here let us start this particular server again. So now this error will go away once this becomes active. Let us wait, and let us go here and hit refresh, again log in. So still this particular node is still the leader. So now if you use vault status, so now as you see here, storage type is Raft, H enabled true, sealed equals true, initialized equals true. So we have to unseal this particular node so that this error will go away. So now again, vault operator unseal. Okay. So now if you hit refresh again, if you log in with the HVS, so as you see here, it is still this is the leader. Both are other two are lost. It's not the leader, but you can still vote. So now if you log in again with 8200 and go to Raft storage, again you can still see the same view. So now as you see here, the error message has gone. It is converted to info here. So info storage Raft pipeline duplication peer voter node 1, it's now up and running. So this is how you set up the node, say 3 nodes, and you can fail the healthy one, active one, and you can become the standby mode will become the active one. So now let us kill the standby one. So here, this is the standby one, and I killed it. So now if I hit refresh and log in, so as you see here, there's no change in this particular snapshot, but you can still write and read because there are 2 nodes which is up and running. So here, so node 1 is up and node 2 is up. So now if you hit say vault status in node 2 and also in node 1, right? So this is the standby mode and this is the active mode. So now what I'm going to do, I'm going to kill this second one. So right now this is also down. So this is down. So I'm going to kill this particular, the active one. So now this node 1 is active, right? So this is down and this is also down. So you do it, what do you think it will happen? Let us check it out. So vault status. So this is in standby mode, and vault status again we cannot issue because this is down, and here also vault status, this also will be down because we don't have the vault up and running. Will this become active? What do you think? No, because it follows the Raft consensus algorithm. So it needs a minimum number of votes to become active. If all 2 nodes, in this case 3, so the 2 is down, so nobody is there to vote. So this will become always a standby. So this will not change into active. So right now we have a true failure. Now we cannot say vault kv get, right? We cannot do that. Or vault say kv put. We cannot do that because it is in standby mode. And now if you go here and hit refresh again, in this particular screen will not give you anything because it is down. So now let us go to 8200. I think this is the 18200, I guess. So let us use this. Let us try vault status first. Is it initialized? Yes. Sealed is false. And let us say vault login. Yeah, because it's in standby mode. So we cannot even log in. So to become active, we need these to be up and running. So let us bring back node 2. Let us wait for a few seconds. So here as you see, term 6 and tally 1, refuser 2, votes needed 2. So it needs 2 votes. So now let us use vault status. Still standby, again vault status. H enabled true. We have to unseal it. So HA mode standby, and this also standby. Now let us wait for a few more seconds. Now this become active. So now you can issue vault kv get, kv v2, it will work. So now if you log in, it will work. So you need at least 2 votes to become one node active. If it lots the majority status, then even if it is standby, it will not become active. So this is how the vault, the Raft architecture works. And here we have to manually unseal it. So that is one of the key thing you have to note. So even if you init one node, you have to unseal it in rest of the nodes. So basically you have to write some bash script to do that in real world use, so that once the pod is, or once the process is down, you can make some automation to make it become active, and also unseal it using the keys which you read it from some secured place. So this is the Raft. So now in next video, we are going to see how you can use the same using the console in the classic console mode and see the difference. So what is the difference between the Raft and how the console works? And thanks for watching. Have a good day.
If you like my dad's videos, please subscribe to QA Insights channel.